Welcome. The title of today's notes worksheet is Parabolas Day 2. It's time for us to expand some of the algebra that we looked at yesterday on the coordinate plane. And so we're going to go ahead and start that piece right here initially. As a matter of fact, just kind of looking at my board. And if you could do this, let's tie those together right there. Standard form. You know what we had yesterday was vertex very simply placed at the origin, made the equation pretty easy to work with. Now guys, if you would, let's highlight this piece. Here's h and k coming back to haunt us again. So let's just rehash a couple things. So if you remember, h and k represented the center of a circle. It represented the center of the ellipse. And now it represents the vertex of the parabola. So we're going to go ahead and use that piece as there is no defined center. So it's the vertex. And hey, we're going to go ahead and highlight it the same way we did yesterday, just moving that parabola either left, right, up, or down off of the origin. That's pretty much it. So let's go for it. Standard form, horizontal parabola, vertex at h and k. And so here's how it works. Excuse me. So in this case, the horizontal one is where the y is squared. So y minus k squared. Remember, k always goes with the y. And then remember, I always kind of look to the right side there. There's my 4p. And instead of x like we saw yesterday, it's x minus h. So it's really just a translation, so to speak, taking 0, 0, and now doing h and k. All right, vertical. Let's go put this in place. Standard form, vertical parabola, vertex h and k. Same premise, of course. In this case, we want to go ahead and have the x being squared. So x minus h squared equals. Here's my 4p, of course, and then y minus k would do it. So you could see what we talked about yesterday with that vertex at the origin. This was just 0, and this was 0. And obviously, it made it very simple to use. Now, obviously, what we're going to do is expand that out a little. All right. We talked a lot yesterday about that p-value. So notice it says the p-value again represents, and here's what I would say, just one more time. It is really the distance from the vertex to the focus and then, again, that's the primary definition, but secondarily, I would also say it is the distance from that vertex to the directrix, but going in the opposite direction of what P wants us to do. So let me put this in place and just write opposite direction. And I think that should suffice. Okay, good. So let's go ahead and take care of business. Why don't we go ahead and sketch one here just as a little refresher, write a good equation. I like example 2 that I see on my board, and then we'll go general form on this, see how your completing the square techniques are working for you. So here we go. Use the equation right there, x minus 3 squared equals 8 times y plus 1. And so we want to go ahead and immediately talk about which direction this is going to open. And so, as I said on the previous lesson, I just look to the right side of the equation, as long as it's kind of written like this, of course. And I've got my 4p, which is positive. So a positive number here in front of a linear term where the variable is y, so I think vertical. So positive, vertical, that's got to be up. So let's go ahead and put this all down here. I have a little room, and so this parabola is opening up. Now, before we start sketching anything here, we need that generation point. We need that vertex to get us started. So that's the case right here, letter B. What is the location of the vertex? Now, don't forget, I'm just going to put it right here. Might not be a bad idea for you to do the same, but we're talking h and k with that vertex. And I'm hoping you're in agreement. Just remember, h always is attached to the x no matter what. It doesn't matter what side. So in this case, I am seeing the h value is 3, and I am seeing the y value, or the k value, excuse me, as -1. So vertex, 3, -1. And that's the key. Remember, it doesn't matter which side these are on, but h is always with the x, k is always with the y. And it always goes h first and k second. All right, well, let's go ahead and put it in place. 3, -1. 1, 2, 3, -1. Let's put a point right there. That is definitely on the parabola. What is the value of P? So we go to our model, and our 4P value is equal to 8, and so P is equal to 2. Nice. And so as a result, we can get D and E based on our definition of P. P tells us primarily how to go from vertex to focus, and I go the same direction as it opens. The focus is inside, so it goes up as well. And so let's just go up 2, and I'm just going to go up right here, up 2, and I'm going to put a little X, of course, right there. Now, remember, just in terms of coming up with the mathematics, when you move up or down on the coordinate plane, which coordinate changes? Well, we talked about this before. It's just the y coordinate that changes. So if I'm going up 2, x is still 3, and just add 2 to this, -1 plus 2 is 1. And that's what I obviously have right here, 3, 1. So if you can count, sure, count. If you can't, obviously just do the math here. Add 2 to the y for going up. Okay, now let's go get the directrix. If I went up 2 to get to the directrix, I'm going to go down 2 and draw the directrix there. So let's go down 2, and then let's draw that perpendicular line, which in this case would be horizontal. And so I have that piece right there. If I was to ask you to model that particular line, remember it is an equation. Please just be very careful on that piece. It's not an ordered pair. It is an equation. And it's a line where all the y values are equivalent to -3. And so there's your linear equation right there, y equals -3. Nice. And same scenario. From the vertex, go down 2. So take away 2 from the y, but write it as an equation. Y is -3. Okay, now we're rolling. Let's see where we are on this. I've done C, I've done D, I've done E. Let's take care of the sketch sort of with the width. So lattice rectum there, I'm just going to go LR is 8 units. Let's see if you can apply it. It'd be great if you could pause the video at this stage and apply it. But remember, it is a line segment that goes through the focus, not through the vertex, but through the focus, and is parallel to the directrix. So let's see, it's 8 units long, and the focus is right in the middle of that 8 units. So basically, if I want to figure out that 8 units, I'm just going to go 4 this way, 1, 2, 3, 4, and 4 this way, 1, 2, 3, and 4. And that's pretty much it. That would give me my 8 with this being in the middle. So again, just one more time quickly, 8 units across through the focus. So at the focus, let's go 4 this way, and there's my 8 units. And now I have it. Nice open curve right there, looking great. This one, how'd I do? Yeah, could have been better, could have been worse. Alrighty, I liked it on this branch a little better, so I'm going to go ahead and pick a point. If you would, do the same. Go to the focus. Go to the directrix. By definition, what do we know about those two distances? They are the same. The two segments that I just drew in there are congruent. Nice. That's looking ideal. So really not too bad, especially from yesterday. Just go use H and K and do the same stuff. Good. Let's do 2. So write the equation of the parabola if the focus is at 1, 3, and the directrix has an equation of y equals -1. All right. Not too bad. Let's see if we can pull this off. I would encourage for problems like this, when all else fails, try to be visual with it. In fact, I'm going to be very specific here. So 1, 3. It's not the vertex, it's the focus. So there's the focus right there at 1, 3. And then the equation of the directrix is just y equals -1. Okay, nice. And I guess just based on those two pieces, we should be able to write the model for this. So let's see, those two things generate the shape of the parabola. So why don't we talk about a couple things here. I guess I would ask you, first and foremost, could you probably tell me where the vertex is based on all of the ideas that we've explored up to this point? Because I don't have it written so far, but can you place the vertex? Okay, well, I would say that the vertex has to be right in between these two, right, by definition? Because if you remember, P is kind of from vertex to focus and also vertex to directrix. So what that means is it's right smack in the middle of the two. So I'm seeing it right there. I hope you agree with that. That vertex now is 2 units away from the focus. It's 2 units away from the directrix. I've got it. Well, long story short there, I think that vertex is at 1, 1. All right, let's put that in, which you, of course, know. Just in case, H and K. All right. Second order of business, once I have that vertex in place, then I can really see it. Are you okay with the fact that this parabola is opening up? Does everyone see that piece right there? It has to open up from the vertex, going towards the focus, essentially the same direction. So it's opening up. And I would say one more thing before I have you write the equation. It looks like from here to here is our p-value, specifically from vertex to focus, and it's 2 units in that upward direction. All right, so we had to do a couple things to get that information. Once we have that information, though, you should be able to write the model. So if you would pause for just a sec and give me a model there. Something on this side, something on this side. Make it happen. Okay, here's what I have. So first of all, I like dealing with the right side first, but I just kind of see the 4p, so 4 times 2 is 8. That looks good right there. And then what goes on this side? Well, if it opens up, along with the 4p is the vertical piece, which is the y, and k, of course, was 1, so y minus 1. Remember, guys, it's not a square over here. The right side is linear. That's key. So don't put a squared on that. I've seen students do that over the years. Don't do that. But it looks like x minus h squared, or how about x minus 1 squared? That's looking good. All right. Nice. All right, so let's go on to the next piece. Quick board right here, I guess. Want to talk about the general form. Here's what's kind of intriguing about the general form of our parabola. Look at this case, both for vertical and horizontal. What do you notice in terms of our equation? Just a pretty explicit difference between the parabola general form and circles and ellipses. Well, the thing that jumps out at me is I only have one of the variables being squared. Everyone see that? In each case. So if it's vertical, it's the x that's squared. We saw that. If it's horizontal, it's the y that's squared. Not both squared. Cool. So I think that's going to make completing the square pretty easy. We only have to do it on one of them. So let's go right to it then. It says on your paper, strategies to convert from general form to standard. Just kind of throwing my 2 cents in there. Number 1, complete the square. Oh, here's the key. There it is. One or the other. Don't have to do it on both here. And then this will be the key for parabolas. In contrast to circles and ellipses, we're going to factor out the coefficient of the linear term. We need that 4p sitting out in front of the linear term, as you've seen. So the good news is I think that completing the square is pretty straightforward. Just make sure it works. So what do you say we run through 3 and then just do kind of a pseudo application on 4? Should get us to where we need to be on this notes worksheet. So here we go, guys. First and foremost, I want to complete the square not on both. In this case, it looks like on the y's, because the y is the only one that has the squared. Always complete the square from the first 2 terms, and you want a 1y squared right there, and I have that, so that's good. Everything else goes, guys. The 12x, move it. The 23, move it. Put something on the back, though. All right. What's going in those blanks? Well, nice and easy here. Looks like 2 divided by 2 is 1. 1 squared is 1. Not doing anything fancy with that 1, so I only added 1 to the left. Let's add 1 to the right. I'm going to go ahead and do this in a couple steps. If you can do it a little more efficiently, more power to you. I'm getting a negative 12x plus 24. Cool. The reason for completing the square is because it factors like this. There's our y minus k squared, by the way. and then factor out the 4p. So the 4p is always going to be this number right here because we just want, in parentheses, x plus or minus our number. So let's take out that 4p, and we'll be a little careful with this, but that's what I want. I just want the x, and plus or minus here, everyone. Minus, when I took out the negative 12 from here, turns to a minus 2. And that's looking great. So there we go. General form, it's nice. Standard form is where all the info is because now we're going to run the gamut here. Let's go vertex. Let's go focus. And let's go directrix. If you can do this without the coordinate plane, be great. I mean, totally, if you need the coordinate plane, use it. But let's put this together. Would love for you to pause and come up with these on your own and then check answers. But if you can't, no worries at all. Vertex, guys, h and k. H is over here, positive 2. K is over here, negative 1. All right, so one piece taken care of. Now the key, everybody, is which direction is this opening? And so I'm going to just write one or two things off to the side here, but I'm seeing this is negative, and x means horizontal, so negative and horizontal. This is going to the left, and I'm hoping you see then that p would be negative 3 as a result. Okay, that looks good. And so let's go vertex to focus by going 3 units to the left. Ooh, and remind me, which coordinate changes when you move to the left? And when you move left, I'm seeing it as the x is changing. So if we're going to the left 3, we're going to take away 3 from the x coordinate. Again, if you can't pull that off, that's all right, of course. Grab a coordinate plane and plot it on there. Go 3 left, and I'm sure it would put you at this, negative 1, negative 1. Directrix, if I went 3 left to get the focus, I go 3 right to get the directrix. And just remember, if I go 3 to the right, from here, go 3 to the right, so add 3 to this, and that's what changed, and it's not a point, it's a line. In this case, it would be a vertical line, and all the x's are the same. And that would be it. So just one more time on that, p was negative 3, and because it's horizontal, take away 3, go into the focus, add 3, go into the directrix. And there it is, x equals 5. Nice. These are relatively fast, so I'm going to go all the way through on letter B. But, you know, to me, the ideal would be you pausing the video at this stage, seeing if you can do it, and then just quickly fast forward and see if you got it right. So here we go. X squared minus 2x, fill in the blank. 8y minus 17, fill in the blank. I'm going with a 1 again, just coincidence, and a 1 right here. How about x minus 1 squared? And I guess I'll do it like this, 8y minus 16. Just have to clean up that right side. Remember, this always comes out from both terms, no matter what, because we always want just the y by itself here. And how does a y minus 2 sound? There you go. Nice standard form. I'm going to go with my big 3 right here, everyone. Vertex, focus, directrix. And I think I'm ready. HK, 1, 2. Focus, well, let's go ahead and do a quick thing here. Positive, vertical, so this is opening up, and P is 2. Good, and if that is the case, if I'm going up 2 on the coordinate plane, that y coordinate is going to change by 2. Up 2 gives me that. And, of course, if I'm going to the directrix, opposite direction, same number of units, let's go from that vertex, let's go down 2. So 2 minus 2 is 0, and because it's a line and not a point, the y is 0 all the way through. Absolutely great. All right, well, I'm hoping that algebra kicks in nicely. Parabolas aren't usually too terrible. Let's go ahead and, as I said, do kind of a pseudo example. There's some great applications that we're going to see on the next notes worksheet. I don't know if we're going to set up that precedent or not, but let's go ahead and take a look a little bit here. So let's see. Roads are often designed with parabolic surfaces to allow rain to drain off. A particular road that is 32 feet wide is 0.4 feet higher in the center than on the sides. Let's change that typo right there. How far from the center of the road is the surface 0.1 feet lower than in the middle? Interesting. All right, well, let's get a little coordinate plane going here. Just kind of thinking about this piece. And parabolic road, can you kind of picture that piece? So a little higher in the center than on the sides. So maybe something like this, give or take. Obviously, this is going to be an exaggeration, but I'm going to go ahead and at least draw it like that to start it out. And I guess what we want to do is label a few things here. I see that's 32 feet all the way across. And then this is 0.4 feet higher here than over here. So for this parabola opening down, I don't know, I think that's pretty good, all things considered. And then we're looking for how far from the center of the road is the surface 0.1 feet lower than in the middle. Oh, okay. Well, let's label a couple points here and see what the heck we have. Are you guys okay if this is 32 across? I mean, I have either one of these points, but are you okay instead of 32, 0, I guess this would be 16, 0. I'm going to just throw a little XY on that, just kind of thinking out loud with this. And then over here, same deal. I don't know, maybe negative 16, 0. I don't think we need both by any means, but the more labeling, the better. Would that be our 32 all the way across? Yeah, I think so. And then as a result up here, this looks to be 0.4, right? And that 0.4 is actually a special point on the parabola. I think we've seen stuff like this before, but that's our H and K. Very nice. Now, what we're going to do before we answer the question here is we're going to model this parabola. The infinite number of points on my drawing here, we're going to model with an equation. Then we'll answer the question. Well, let's go for it. So here's a couple questions for you as you're thinking about this. It's opening down, and H is this and this right here. Okay, so let's deal with the right-hand side. I know that my equation has a 4 and a P. I haven't seen anything about a focal point, so no focus just yet. But I do have just about everything else, don't I? So I have 4P, and I have Y minus K, and I've got an X and a Y down here, or an X and Y here. Are you guys following this piece? So actually, let me do this first. It's opening down, so again, sometimes just kind of thinking out loud here, let me catch up to myself and put that in. So I hope you're all right with that being the generic model. That's the key. Should have started there. Now I thought of it. All right, so here's what I see. We have X, we have H, we have Y, and we have K. And the only thing missing is P for us to write the model. And this constant does have to be in front of our linear term here, so we need it. So let's go ahead and fill in. I'm going to go ahead and start just X being 16. H being 0. Just don't forget the squaring on that. I've got a 4 times the P, and then I've got a Y value of 0, and K being 0.4. Okay, very nice. I can do a little of this in my head, but this is going to be 16 minus 0 squared. I'm seeing that as a 256, and then a 4 times P times negative 0.4. Okay, all looking pretty good. I have a 256, and then equals, we would do this right over here. How does negative 1.6 P sound to everybody? Now in this case, again, if I'm going to write my model, I need P, and then kind of go right back again and multiply it by 4 to get my 4P. But let's get that focal distance, essentially, from vertex to focus there. I'm going to bring my calculator up, and let's get that 256 divided by negative 1.6. All right, is everyone okay with that piece? That really the P is negative 160 on this, which I know seems a little strange because we're going to go back and then immediately multiply it by 4 again to get our coefficient in front of the linear term. But whatever, I'm going to go ahead and do it. It's just good practice here. So I think we're ready to roll. So I'm getting now h and k are given. So I'm getting x minus 0 squared, which is x squared, 4 times p, so 4 times p, which was negative 160. So 4 times negative 160 should be negative 640. And then I have y minus k, and so I have y minus this 0.4 right here. Take a look at that if you get an opportunity. See if it's clicking. And I think just what I see is that looks like a nice model for our parabolic road right here. Really, really cool. If I have an x, I can find a y. If I have a y, I can find an x, and that's what I want. So it says, last piece, how far from the center of the road is the surface 0.1 feet lower than in the middle? All right, let's be a little careful with this. So here we're up at 0.4. As I go more to the right or to the left, start to go down, I want to know how far I have to go for it to be 0.1 lower. So that would be that the y value is not 0.1, but 0.3. I think that's what we're trying to find. So again, 0.3 is the y, and what is the x? Hoping that works. So let's do it. So x squared equals negative 640. And now I have my y value as 0.3 and then minus the 0.4. You guys okay if I just go ahead and do this on the calculator, maybe undo that square, and maybe do it all in one shot there. Let's see if I can pull this off. I have negative 640 and then times 0.3 minus 0.4. Close it. And I get 64. Yeah, nice. Little square root on that. We know what we're going to get. And there we have it. So it looks, based on the situation here, I would be going 8 units to the right, 8 units to the left, and that's the deal. So I'm going to write x equals kind of a plus or minus 8 on that. Let's see if we want to answer the question a little better. How far from the center? So how about 8 feet from the center? Super. That's looking great. We're going to do, as I said, some good applications on the next notes worksheet here, but this at least starts the conversation a little bit. Okay, well, let's wrap this one up. And if you have some questions on some of the algebra here, please don't hesitate to ask. Just let me know. Great, thanks.